Good evening, friends. Welcome to Unacademy GATE ESE. This is your educator Aprup Rao, and you are watching the revision through formula and question series of strength of material. In this lecture series, our objective is to revise the entire subject, strength of material, through very important concepts, very important formula, and very important questions. We are in our lecture number 4. We have already covered 2 chapters, basics of stress and strain and axially loaded members. This will be your 3rd chapter, torsion in circular shaft. In today's lecture, we are going to revise the entire torsion in circular shaft. We are going to see all the important concepts, all the important formula, all the sign convention, how to use that formula, and then we are going to solve some very most expected questions from torsion in circular shaft. So all the GATE 2021 aspirants must watch this lecture series because your entire strength of material is going to be revised. So good evening Ankita, good evening Manikanta, good evening Shivam. I welcome all of you. Now those of you who are watching me live, please hit the like button and please share the link of this lecture with all your friends, all your groups. It will be a great help to all of those people who are studying for GATE 2021, because there are some people who really need these types of lectures. This is the last few days of GATE 2021 preparation, and during this time the most we need is revision strategy. The most important thing right now is revision strategy, how to revise the subjects that you have already studied, how to make short notes, how to remember the formula. All of that is very important at this crucial time. So this lecture series is going to really help those people who want to revise strength of material, and the PDF of this lecture you can use as short notes. आप इस लेक्चर के पीडीएफ्स को सेव कर सकते हैं और ये आपके शॉर्ट नोट्स की तरह काम आएंगे. हर एक लेक्चर में मैं एक चैप्टर कवर कर रहा हूं, तो उससे आपका एक लेक्चर का शॉर्ट नोट्स प्रिपेयर हो जाएगा हर एक पीडीएफ से. तो आपको एंड टाइम पे अगर स्ट्रेंथ ऑफ मटेरियल रिवाइज करना है, इफ यू वांट टू रिवाइज स्ट्रेंथ ऑफ मटेरियल ड्यूरिंग द वेरी लास्ट टाइम, then beta you can refer to these short notes. These are really going to help you, because in these short notes you will find entire concept of strength of material, all the formula that you need to remember, all the sign convention, everything that you need to keep in mind regarding strength of material. तो मेरे भाई जल्दी से लाइक बटन दबा के अपनी अटेंडेंस दे दो और जल्दी से शेयर कर दो, ताकि ज्यादा से ज्यादा बच्चे लाइव देख सकें और मेरी भी एनर्जी जो है वो बढ़ी रहे हमेशा. ओके, गुड इवनिंग सुनील, गुड इवनिंग स्टेवन, वेलकम एवरीवन. नाउ दोज ऑफ यू हु आर वाचिंग मी फॉर द फर्स्ट टाइम, let me introduce myself. My name is Aprup Rao, all India rank 320 in GATE Mechanical. I've done my MTech from IIT Kharagpur and my specialization was Mechanical Systems Design. Then I was recruited by Mahindra and Mahindra, and I was placed at Mahindra Research Valley, which is the R&D center of Mahindra. I worked there as deputy manager for 2 years. Then I quit my job and I decided to teach. So I've been teaching for more than 6 years now. And I teach subjects related to design, strength of material, machine design, engineering mechanics and theory of machine. But this is not the reason why I am here in front of you. I am here in front of you every day because of my love and passion for teaching. And if you have followed my lectures regularly, then I can guarantee that you might have fallen with this in love with these subjects, right? Now, if you want to watch my lectures, then beta you don't need to search, you don't need to go anywhere, you don't need to worry. All the lectures of these subjects you can find at one place. This is the link that you need to open, tinyurl.com/aprup10. Just open this link, tinyurl.com/aprup10, and you will find all my lectures at one place. You will find all the PDF notes, you will find all the ebooks, everything that you need for the preparation of subjects of design. डिजाइन के सब्जेक्ट्स प्रिपेयर करने के लिए आपको जिन चीजों की जरूरत है, जो भी रिसोर्स चाहिए, वो सारी चीजें आपको एक जगह मिल जानी है, tinyurl.com/aprup10. So just open your browser and type this, and you will open this page where you will find these Excel sheets. Open any of these Excel sheets and you will find the links of all my classes. So beta, I have taken classes on the entire syllabus of SOM, EM, MD, TOM. You'll find everything in these Excel sheets. Okay. So don't forget about tinyurl.com/approved10. You can also follow my Unacademy profile. This is my Unacademy profile link, unacademy.com/@approved. Go to this and you will find my Unacademy profile where you can find my free special classes. Special classes means free classes. Everyone can watch them without any subscription. So you can see that I have taken special classes on some very important topics. All the newly added topics of GATE, all the very important topics of GATE, all the PYQs, everything that you need in order to study the subjects of design, you will find here also special classes. Now, if you want to watch these classes, what you need to do is just download the Unacademy learning app, register yourself, and then when you will try to open your first special class, they will ask you to use an invite code. Now you can use this invite code approved10. This will be the code to open all the special classes, not only mine, all the special classes. Okay. So if you are using Unacademy learning app for the first time, then you will have to use this code. Okay. So don't forget to watch my special classes on Unacademy by downloading the Unacademy learning app and using approved10 as your code. Okay. Now, if you want to study with some legendary teachers of India, if you want to prepare with us, then you can take the Unacademy Plus subscription, where you will get live classes in English as well as in Hindi. You will get doubt solving sessions, you will get weekly tests, crash courses, rank improvement batches, etc. And if you want to go one step ahead, you can also take Iconic subscription, where you are going to get a personal coach who will personally see that you are going towards your goal, who will help you on a personal level, जो personal level पे जाके आपको push करेगा आपके goal की तरफ. He will make all the schedule for you, he will prepare all the study material, he will analyze all your tests, he will take one-on-one sessions with you so that he can help you on very personal level. Okay. Now all you need to do is go to Unacademy app and choose any one of these subscription, and while you are taking the subscription, you can use this code in order to get 10% off. Now I will tell you more about the subscription at the end of the lecture. Okay. Now if you see the syllabus of strength of material, we have already covered introduction to stress, introduction to strain, material properties and axially loaded member, and today we are going to cover torsion in circular shaft. आज की जो क्लास है उसमें हम एक बहुत इंपॉर्टेंट चैप्टर कवर करने वाले हैं, which is what? Torsion in circular shaft. इस चैप्टर में हम टॉर्शन के सारे कॉन्सेप्ट्स पढ़ने वाले हैं. इन दिस चैप्टर वी आर गोइंग टू कवर द एंटायर कॉन्सेप्ट्स ऑफ टॉर्शन इन सर्कुलर शाफ्ट, whatever formula you need to remember, what are the sign convention in that formula, and then we are going to solve some very expected questions from torsion in circular shaft. किस टाइप के क्वेश्चन यूजुअली आते हैं, किस टाइप के क्वेश्चन आप एक्सपेक्ट कर सकते हैं. नाउ दोज ऑफ यू हु आर वाचिंग मी लाइव, प्लीज गिव मी अ लाइक बटन राइट नाउ and please share the link. Please share the link. I will keep on telling you to share the link until and unless these videos reaches to maximum number of students. I will always do this because I really want that all the students in India who need these lectures should get their hands on these lectures. हर उस लड़के, हर उस स्टूडेंट के पास ये लेक्चर्स पहुंचे जिनको इन लेक्चर्स की सच में जरूरत है. ठीक है, तो इसके लिए मुझे हर लेक्चर में आके 100 बार भी रिपीट करना पड़े, देन भी उसके बावजूद भी मैं रिपीट करता रहूंगा दैट यू नीड टू प्लीज शेयर द लिंक ऑफ दिस वीडियोस टू ऑल योर फ्रेंड्स, ऑल योर ग्रुप्स. ओके, थैंक यू सो मच. हेलो शुभम, कल्पेश, अभिषेक, विकास, साई वरुण, वेलकम एवरीवन. Now call your friends also beta, call your friends also. The attendance should be high. Attendance इससे ज्यादा होनी चाहिए तभी एनर्जी बनेगी, right? So let's start with today's lecture, torsion in circular shaft. Okay. So beta, what do we mean by torsion? Torsion means twisting moment. It is a moment acting about the normal axis. You can see that this is the normal axis of the cross section, right? This is the cross section. This is the cross section. This is the normal axis of the cross section. So torsion is moment acting about the normal axis of the cross section. ठीक है, मैं यहां पे नोट कर देता हूं, torsion is moment acting about the normal axis of the cross section. The moment acting about the parallel axis of the cross section is known as bending moment, but twisting moment is the moment acting about the normal axis of the cross section. ठीक है, आप देख सकते हो, this is the normal axis और इस axis के about लग रहा है twisting moment. Okay, now under twisting moment we need to calculate the shear stress and the deformation, but in order to derive the equation of torsion we make certain assumptions. You need to remember those assumptions. You might get 1 mark questions based on those assumptions. ठीक है, so it is very important to remember these assumptions also. So let's see what are the assumptions. So the first assumption is material of the shaft is homogeneous and isotropic. This is an assumption in every chapter. Material is homogeneous and isotropic. Second assumption is stresses are within proportional limit. Now I have already told you, why do we assume this point? Stresses are within proportional limit. Why do we assume this? Because if stresses are within proportional limit, Hooke's law will be valid, and in the derivation of torsion formula we use Hooke's law. In every chapter we use Hooke's law. That's why we need to assume that the stresses are within proportional limit. Okay, the third and very important assumption based on which we get the torsion formula is all the transverse section remain plane and undistorted after twisting. In other words, we can say that the diameter of the shaft remains straight after twisting. What do we mean by this? If you look at the cross section, अगर आप क्रॉस सेक्शन ऑफ द शाफ्ट देखें, लेट्स से दिस इज द क्रॉस सेक्शन ऑफ द शाफ्ट, ओके, एंड दिस क्रॉस सेक्शन इज सब्जेक्टेड टू अ ट्विस्टिंग मोमेंट. ये क्रॉस सेक्शन जो है इसके ऊपर क्या लग रहा है मेरे भाई? इसके ऊपर लग रहा है एक ट्विस्टिंग मोमेंट. ओके, नाउ कंसिडर एनी वन डायामीटर ऑफ द शाफ्ट. लेट्स कंसिडर दिस डायामीटर ऑफ द शाफ्ट. ओके, so you can see that right now this diameter is straight. After applying twisting moment, our assumption is that this diameter will remain straight like this. This diameter will remain straight like this. And what does this mean? The diameter remains straight means what? अगर diameter straight रहेगा तो मेरे भाई क्या होगा? अगर डायामीटर स्ट्रेट रहेगा तो उसकी वजह से क्या होगा? इफ द डायामीटर इज स्ट्रेट देन द इंटरनल फोर्सेस विल बी लीनियर, राइट? इंटरनल फोर्सेस विल वेरी linearly. This is the assumption based on which we derive the torsion formula, right? So beta, you need to remember this, that the diameter of the shaft will remain straight after twisting. Okay, so due to this we get linear variation of torsional stress. Okay, thank you so much Swati, thank you so much. Good evening Zubair, Prem, good evening Swapnil, good evening Grubler Chacha, good evening, good evening. Now beta, let's move on to the torsion formula. So based on these assumptions we derive this formula given by T by J equals to tau by R equals to G theta by L. Okay, so this is the torsion formula. Now let's understand the meaning of each and every term of this formula. So I will bring the cross section first here. So this is the cross section of the shaft. Okay, this is the axis about which the twisting moment is acting. Okay, now first of all T is what? T is what? T क्या है मेरे भाई यहाँ पे? T जो है वो internal torque है. T is the internal torque. Okay, how much internal torque is resisted by this cross section? Now what is J? J is a very important term which is what? पोलर मोमेंट ऑफ इनर्शिया। अब पोलर मोमेंट ऑफ इनर्शिया क्या होता है मेरे भाई? पोलर मोमेंट ऑफ इनर्शिया मीन्स मोमेंट ऑफ इनर्शिया अबाउट दिस नॉर्मल एक्सिस. Okay, simply if I say moment of inertia, that means it is about the parallel axis, x axis, y axis. That is simple moment of inertia. I. J is polar moment of inertia, which is the moment of inertia about normal axis. मैं यहां लिख देता हूं, it is moment of inertia about normal axis. Okay, now what is tau? Tau is the shear stress. Tau is the shear stress at a distance r. अब टाउ क्या है मेरे भाई? टाउ जो है वो shear stress है at a distance r. So let's say I consider a point here which is at r distance. Okay, which is at r distance. So tau will be the shear stress at this point. So you can see that at every point the shear stress will be different. Okay, now in this equation, what is theta? Now theta is a very important term. It is known as angle of twist. Now what do we mean by angle of twist? Let's say that there is a cross section, there is a diameter initially like this, and after twisting moment the diameter is twisted like this. So beta, this angle of twist, this angle theta is known as the angle of twist. कितने एंगल से क्रॉस सेक्शन जो है वो ट्विस्ट हुआ है, that is known as angle of this twist. Okay, so these are the things you need to remember. Now in this equation there are two things that you calculate. What? Maximum shear stress tau and angle of twist theta. यहां दो चीज हम कैलकुलेट करते हैं, एक तो maximum shear stress tau and angle of twist theta. Okay, अब मैक्सिमम shear stress बोलने का मतलब मेरे भाई क्या है? What do we mean by maximum shear stress? So understand, in the entire cross section shear stress is not constant. Shear stress vary from one point to another point. For example, if we consider this layer, अगर मैं इस लेयर की बात करूं या इस लेयर की बात करूं, वर्टिकल लेयर की, then shear stress from one point to another point will vary. And how it varies? It varies linearly. Shear stress varies linearly like this. Okay, and the shear stress on the surface means here and here will be maximum. This is tau maximum. Okay, now beta, we need to remember the equation of tau maximum. So how do we get the equation of tau maximum? T by J is tau by R. So if you put R maximum, you will get tau maximum. And for a solid circular shaft, the equation of tau maximum is given by tau maximum equals to 16T by pi d cube. This is the equation for solid circular shaft. And for hollow circular shaft, the same equation will become tau maximum equals to 16T by pi d outer cube 1 minus k to the power 4, where k is what? K is what? K is the ratio of inner diameter and outer diameter. Okay, so this is for solid shaft and this is for hollow shaft. So you need to remember this direct formula. Okay, even if you don't remember them, you can always use this equation, T by J equals to tau by R. I have just solved this equation and I have directly got this equation of tau maximum. Tau maximum equals to 16T by pi d cube for solid circular shaft and 16D by pi d outer cube 1 minus k to the power 4 for a hollow shaft, where k is inner diameter by outer diameter. Okay, so beta, they will ask you to calculate tau maximum. Okay, then the next thing that usually we calculate is the angle of twist. अब angle of twist का formula क्या हो जाता है? What is the equation of angle of twist? theta equals to T into L by G into J. This is the equation of angle of twist. Okay, अब इस इक्वेशन में एक चीज बहुत जरूरी है and that is theta here is in radians. ठीक है, थीटा जो हमको मिलता है वो किस में मिलता है, रेडियंस में मिलता है. ओके, एंड वी नीड टू कन्वर्ट थीटा इनटू डिग्रीज बाय मल्टीप्लाइंग पाई बाय 180 बाय पाई, बिकॉज यूजुअली इन क्वेश्चन they ask you to calculate theta in degrees. So mere bhai, you have to convert radian into degrees. Okay, so in this formula theta is in degrees. Okay, so beta, this is the equation of angle of twist, theta equal to TL by G into J. Is it clear? Now beta, here you need to understand one thing. Let's say we have a stepped shaft. मान लो अपने पास एक स्टेप्ड शाफ्ट है. ओके, एंड इट इज सब्जेक्टेड टू सम टॉर्क T. ओके, लेट्स से दिस इज पॉइंट A, दिस इज पॉइंट B, दिस इज पॉइंट C. So if I ask you to find angle of twist at A, then you will calculate angle of twist from A to C. And how you calculate it? You will add theta AB and theta BC. Okay, and if I ask you to calculate angle of twist at B, then what you will calculate? Will you calculate theta AB or will you calculate theta BC? So understand, if I ask you to calculate angle of twist at B, you will calculate theta BC. Now why theta BC? Why not theta AB? Understand, if I calculate theta AB, then A is also getting twisted, B is also getting twisted. So theta AB will not be the angle of twist of B. It will have angle of twist of A plus angle of twist of B. A is also twisting, B is also twisting. But if I calculate theta BC, then theta C is 0. C is not twisting, C is fixed. So if I calculate theta BC, it will be the angle of twist of only B. So do you understand, if you need to calculate the angle of twist of any point, then you need to calculate angle of twist of that point with respect to a fixed point. Okay, now beta, please hit the like button. I am seeing that more people are watching live कंपेयर टू द नंबर ऑफ लाइक्स. अब ये तो नहीं होना चाहिए ना, जितने बच्चे लाइव बैठे हैं उससे कम लाइक्स तो नहीं होने चाहिए, तो सबके सब लाइक्स तो जरूर दबा दो. तो हियर बेटा, यू नीड टू रिमेंबर वन थिंग, दैट आउट ऑफ दीज टू दिस C मस्ट बी फिक्स्ड. ठीक है, थीटा AC, थीटा A निकालना है, थीटा AC, थीटा B निकालना है, थीटा BC. Why C? Because C is fixed. Okay, so beta, do you understand how to calculate the angle of twist? Beta, I am telling you this because they will ask you in exam, what is the angle of twist of A, what is the angle of twist of B. Okay, so do you understand the concept of angle of twist? Now you need to remember a few more things. When it comes to torsion, you need to remember a few more formula. ठीक है, for example polar section modulus. अब ये एक बहुत important property है, this is a very important parameter, polar section modulus. Now what do we mean by polar section modulus? Polar section modulus is the measure of the strength of the shaft. Now what do we mean by strength? How I will say that this shaft is stronger than this shaft? What I will compare? So beta, strength means how much torque I can apply on the shaft without failure. ये shaft कितना torque झेल सकता है? If I apply torque, then it will try to fail this shaft, it will try to fracture this shaft, or it will try to yield the shaft. Okay, so beta, how much torque this shaft can sustain without failure, that will be known as the strength of shaft. And if you want to measure the strength of shaft, then you need to calculate the polar section modulus. So polar section modulus is the angle of, it is the measure of the strength of shaft. How strong is your shaft? Now this parameter depends upon the shape and size of the cross section. ये जो पैरामीटर है पोलर सेक्शन मॉड्यूलस, ये डिपेंड करता है शेप एंड साइज ऑफ क्रॉस सेक्शन पे। इसको हम ZP से डिनोट करते हैं एंड ZP इज गिवन बाय J upon R maximum. ZP is given by J upon R maximum. Now understand, in this equation, J is polar section modulus, J is polar moment of inertia, and R maximum means maximum radial distance. Now maximum radial distance means distance from center to surface. सरफेस के पॉइंट का डिस्टेंस सबसे ज्यादा होगा, सो आर मैक्सिमम मींस डिस्टेंस फ्रॉम सेंटर टू सरफेस। ओके, तो बेटा ZP इज J बाय R मैक्सिमम। अब सॉलिड शाफ्ट के लिए ZP की वैल्यू क्या हो जाती है? फॉर सॉलिड शाफ्ट ZP विल बी इक्वल टू पाई बाय 16 d क्यूब, एंड फॉर हॉलो शाफ्ट ZP विल बी इक्वल टू पाई बाय 16 d outer cube 1 minus k to the power 4. Okay, so this is the formula of polar section modulus of solid shaft and hollow shaft, but you don't have to remember this because beta you can put the value of J and R maximum and you can calculate it on your own. Now here you need to understand one thing. For same cross sectional area, ZP of hollow shaft will always be equal to greater than ZP of solid shaft. अगर एरिया सेम है, एक ही एरिया है, मतलब टोटल एरिया इज सेम ऑफ अ सॉलिड शाफ्ट एंड अ hollow shaft, then beta ZP of hollow shaft will always be greater than ZP of solid shaft. Means T maximum, how much torque it can resist of hollow shaft will be greater than T maximum of solid shaft. Now T maximum मतलब क्या? This is the strength only ना, यही तो strength है मेरे भाई, this is the strength only. तो इसका मतलब क्या है? If the cross sectional area of a hollow shaft and a solid shaft is same, then the hollow shaft will be stronger than solid shaft. It will be able to resist more torque compared to solid shaft. Is this clear to everyone? क्या ये सबको क्लियर है मेरे भाई? इसी बात पे ठोको लाइक्स, प्लीज हिट द लाइक बटन एंड प्लीज शेयर द लिंक टू एज मेनी पीपल एज यू कैन। ओके, तो मेरे भाई दिस इज क्लियर आई होप टू एवरीवन। ओके, polar section modulus, what do we mean by polar section modulus? What is the significance of this? This will tell us how strong your shaft is. पोलर सेक्शन मॉड्यूलस का क्या सिग्निफिकेंस होता है कि ये हमको बताता है कि कोई शाफ्ट कितनी स्ट्रॉन्ग है। ओके, नाउ नेक्स्ट थिंग यू नीड टू रिमेंबर इज टॉर्शनल रिजिडिटी। व्हाट डू वी मीन बाय टॉर्शनल रिजिडिटी? सो बेटा टॉर्शनल रिजिडिटी इज द मेजर ऑफ द रिजिडिटी और यू कैन से रेजिस्टेंस टू डिफॉर्मेशन। रिजिडिटी इज व्हाट? Resistance to deformation. So when you apply torque, that torque will try to twist this shaft. So how much it can resist that twisting? That will depend upon torsional rigidity. If rigidity is more, then angle of twist will be less. So torsional rigidity is equal to G into J. ठीक है? Torsional rigidity is equal to G into J. If rigidity is more, then angle of twist will be less. ठीक है? तो मेरे भाई GJ अगर ज्यादा है तो थीटा कम होगा. Okay, so do you understand what do we mean by torsional rigidity? Next is torsional stiffness, very similar to rigidity. What do we mean by torsional stiffness? Stiffness in general is the load required for unit deformation. Stiffness का मतलब क्या है? Load required for unit deformation. Now here what is the load? In case of torsion, the load is torque. And what is the deformation? The deformation is angle of twist. So what do we mean by torsional stiffness? Torsional stiffness, which is T by theta. Torsional stiffness will be T by theta, which will be equal to GJ by L. Torsional rigidity per unit length. Okay, torsional rigidity per unit length. So torsional stiffness means T by theta, torque required for unit angle of twist, and it will be equal to Gj by L. So beta, this is torsional stiffness. Okay, so torsional rigidity and torsional stiffness are also important terms. You need to remember them. Okay, kabhi kabhi sometimes you have to use them in theory, sometimes you have to use them in numericals. Okay, next, how to calculate internal torque. So let's say you need to calculate theta and there is a stepped shaft which is subjected to different torque. So beta, you need to calculate T of every part. You need to calculate T of AB, T of BC, T of CD. Okay, so how do we calculate that? Very easy beta, very easy. Let's say you need to calculate T of AB. So consider a plane in AB. ठीक है, एक प्लेन ले लो AB में, and just like you calculate internal force P, you calculate internal torque TAB. Okay, so beta, how we will calculate it? From left, if you see left, say 100 Newton meter, let's say is positive, so this will be 100 Newton meter left say. But right say, if you see left say if 100 is positive, right say this one will be positive, 240 will be positive. Left से अगर ये positive है तो right से इसका उल्टा positive. So बेटा this will be 240 minus 360 plus 220. Again you will get what? Again you will get 100. 240 plus 220, 460 minus 360, 100. Similarly, if I consider a plane between B and C, then TBC will be equal to what beta? Left say 100 is positive, so 240 is negative. So how much you will get? Minus 140 Newton meter. Okay. Now beta, what do we mean by negative sign? So beta, here negative sign does not have a universal meaning. For example, in axial loading, negative signs means compression, positive sign means tension. But here positive negative doesn't have an absolute meaning. But if you are getting one positive and one negative, it means that the twisting in AB and BC are opposite. If one is getting twisted like this, if one is getting twisted like this, other one is getting twisted like this, opposite to this. ठीक है, तो मेरे भाई पॉजिटिव नेगेटिव का कोई यूनिवर्सल मीनिंग नहीं है. देयर इज नो यूनिवर्सल मीनिंग ऑफ दिस, बट positive negative means the angle of twist of AB and BC are opposite. Okay, the direction of twist is opposite. Okay, now in CD, if I want to calculate the internal torque, then again I will consider a plane in CD. Now I can calculate torque from left, I can calculate torque from right. Okay, अब यहां एक चीज ध्यान दो, लेफ्ट से I considered this to be positive, right? 100 to be positive. तो right से this one will become positive. यहां sign convention का ध्यान देना मेरे भाई, ठीक है? I will let you know the sign convention. So मेरे भाई, let's say this is my shaft, okay? So बेटा लेफ्ट से मैंने ऐसा साइन कन्वेंशन लिया है, ठीक है? लेफ्ट और राइट से I have considered this sign convention. साइन कन्वेंशन मैं आपको बता देता हूं ताकि आपको कोई भी confusion ना रहे. Okay, so I have considered this to be positive and this to be negative. Okay, तो यहाँ पे ध्यान दो बेटा, right से if I am seeing, then this one will be positive ना. Left से if I am seeing, then this one will be positive. तो left से 360 and 100 will be positive, 240 will be negative. 360 plus 100, 460 minus 240, 120. Right से, sorry, 360 plus 100, 460 minus 240, 220, and right say 220. So beta, this will be 220 Newton meter. Okay, now beta, if you don't want to get confused in sign convention, अगर आप sign convention का लोचा नहीं पालना चाहते, sign convention की tension नहीं पालना चाहते, then the best thing you can do is that you consider the internal torque from any one side. Okay, don't take internal torque in one case from left, in one case from right. No, you calculate internal torque from only one side. सबका left से निकालो या तो सबका right से निकालो. Okay, then there will be no confusion, then there will be no doubt. Okay, So you will not have to use sign convention if you are calculating internal torque all from left or all from right. ठीक है, चलो. So beta, this is the calculation of internal torque. Now the next topic is statically indeterminate shaft. Now you get a lot of question from this topic. इस topic से बहुत सारे question आते हैं, ठीक है, इस topic से बहुत सारे question आते हैं statically indeterminate shaft. So what do we mean by statically indeterminate shaft, beta? Let's say that we have a shaft which is fixed at both the ends. ठीक है, इस shaft को दोनों ends पे हमने fix कर दिया है, and now we are applying a torque in between the ends. Okay, let's say this is A, this is B, this is C. So beta, if you calculate the reactions at both the ends, if you draw the free body diagram, अगर मैं free body diagram draw करूं, then I am applying a torque here at point B. So in order to resist this, there will be some reaction here, there will be some reaction here, right? So beta, right now I don't know the direction of reaction. So what do we do? If we don't know the direction of reaction, we assume some direction. So let's assume that the torque at A is acting like this and the torque at C is acting like this. This is just our assumption. So how many unknowns do we have? T will be given. T will be given. So let's say T is known. So how many unknowns do we have? 2, TA and TC. And how many equilibrium equation do we have? 1. Equilibrium equation हमारे पास एक ही है. What is the equilibrium equation here? What is the equilibrium equation here? The equilibrium equation here is summation of m equals to 0. Net moment will be 0. These are moments na, twisting moments. So net moment must be 0. So वहां से you will get TA equal to T plus TC. So this is what? This is the equilibrium equation. So beta, we have 2 unknowns and 1 equilibrium equation. So these type of problems are known as statically indeterminate problem. This is a statically indeterminate shaft. Now I have already explained in so many lectures. What do we mean by statically indeterminate? Physical meaning of statically indeterminate. This is a mathematical meaning, that number of unknowns are greater than number of equations. But physical meaning is what? So when you constrain the deformation of a body, if you apply load, then there will be deformation. When you constrain that deformation, when you don't allow free deformation, if you are allowing free deformation, no problem. But when you don't allow free deformation, when you constrain the deformation in some manner, then it becomes statically indeterminate. Okay, how we have constrained this body? If this body was fixed only at one end, then if I apply torque, it can freely twist. अगर मैंने सिर्फ एक एंड को फिक्स किया और फिर मैंने टॉर्क लगाया, then बेटा it will freely twist. But if I have fixed both the ends and then I apply torque, then it will not be able to twist. So I have constrained the deformation of this body. So what will be the equation of that constraint? That equation is known as compatibility equation. इतने सारे ET आ गए हैं इसमें. Compatibility equation. Now what do we mean by compatibility equation? It is the equation of constraint of deformation. So beta, how the deformation is constrained? If I fix both A and C, means angle of twist from A to C, theta AC is 0. And beta, theta AC can be written as theta AB plus theta BC. Why? Because AB and BC में the internal torque is different. So beta, I will divide this in theta AB plus theta BC. Now beta, what is the equation of theta? TL by GJ. So can I write theta of AB as T of A, TA. What will be the torque in AB? TA multiplied by length of AB divided by G of AB into J of AB. Okay. Now here you can see that I have taken torque A, TA as positive. From left side I have taken TA as positive. So from right side TC will be positive, right? Look at the sign convention. Left से ये positive है, तो right से ये positive है. Okay. If you are considering TC like this, then your TC will be negative. But if you are considering TC like this, then it will be positive. So beta BC में it will become TC into LBC by GBC into JBC equals to 0. So beta this is the second equation you have got. Now you have two equation, equation number 1, equation number 2. So by solving these two equation you will get the value of TA and TC. आपको TA भी मिल जाएगा, आपको TC भी मिल जाएगा. Is this clear? Is this clear? Is this clear? Beta Gunsagar, if you want to know how to download the PDF, then watch initial 10 minutes of the lecture. Okay, I explain everything in my lectures in the beginning. So beta please look at the 10 minutes, initial 10 minutes of the lecture. Okay, start the lecture from the beginning. Don't skip the initial part. Otherwise you will miss the crucial information that I give. Okay, आप लोगों की गलती यही है कि आप लोग सोचते हो कि शुरू के 5-10 मिनट तो कुछ होता ही नहीं है. बेटा इंपॉर्टेंट चीजें बताई जाती हैं, उनको सुना करो. ओके, चलो. Now beta, next is composite shaft. Now composite shaft itself is a statically indeterminate shaft. And what do we mean by composite? Composite means made of different material. So let's say we have a shaft which is made of steel. It is made of steel and aluminum. ठीक है, एक एग्जाम्पल के लिए मैं बता रहा हूं, इसको उल्टा कर लेते हैं. Let's say this is steel, this is aluminum. Why I have done this? Because practically if you want to make a composite shaft, then you will always see that the stronger material is away from the axis of rotation. ठीक है, strong material जो है वो axis of rotation से दूर होना चाहिए. Okay, so steel and aluminum like this. Okay, now beta I am applying a torque T here. So if I apply torque T on the composite shaft, some of that torque will be resisted by steel and some of that torque will be resisted by aluminum. Let's say the torque resisted by steel is Ts and the torque resisted by aluminum is Ta. ठीक है, तो मेरे भाई torque resisted by steel and aluminum are Ts and Ta. अब यहां पे you need to find the value of Ts and Ta. So how do we get the value of Ts and Ta? In order to know that, we need two equations. Okay, in order to calculate Ts and Ta, we need two equations. So how we will calculate how we will get the two equation? The first equation will be the equilibrium equation. एक equation तो equilibrium equation हो जाएगी. Ts plus Ta will be equal to T. This will be your first equation. ठीक है, Ts plus Ta will be equal to T. ये आपकी एक equation हो गई. But we need another equation and that second equation is going to be the compatibility equation. अब वो जो second equation होगी वो compatibility equation होगी. How we will get the compatibility equation? Understand. बेटा compatibility equation means constraint of deformation. ठीक है, compatibility equation क्या है? Compatibility equation means constraint of deformation. Okay, so beta how the deformation is constrained here? When I apply torque T, whatever angle of twist will be developed in steel, the same angle of twist will be developed in aluminum also. जितना भी steel में angle of twist develop होगा, उतना ही angle of twist aluminum में develop होगा, right? So beta this is the constraint of deformation, that the angle of twist of steel and angle of twist of aluminum will be equal. Okay, now beta what will be the equation of theta? It will be T into L by G into J, right? अब L जो है that will be same for steel and aluminum, so that will be cancelled The rest of the things you need to put and you will get the TS and TA. Okay, अब आपको TS और TA की वैल्यू मिल जाएगी. Good evening, good evening, good evening, good evening. Welcome students, welcome, welcome, welcome. Now just a minute, give me 1 minute. There is something wrong here, I think. Okay. So do you understand here how to solve the problem of composite shaft? It is just like statically indeterminate shaft. One equation you will get from equilibrium, one equation you will get from compatibility. Okay. So this is how you solve the problems of composite shaft. The next topic is strain energy stored due to torsion. Now beta, strain energy is the energy stored due to deformation. In every chapter, you will see how to find strain energy. So in axially loaded members, we saw strain energy. Now in torsion also we need to see strain energy. So let's say we have a shaft which is subjected to a torque T. Okay. So beta, the equation of strain energy here is given by this. U equals to T square L by 2gj. This is the equation of strain energy, T square L by 2gj, and it is in Newton meter or joules. ठीक है, the unit is Newton meter or joules, Newton meter or joules. Okay. So beta, strain energy के ऊपर till now there has been one question, but it is also an important topic. So U की equation you need to remember, T square L by 2gj. So this is all you need to remember in torsion. Torsion में मेरे भाई इससे ज्यादा कुछ है ही नहीं. There is nothing more than this in torsion. Torsion में if you want to remember, you need to only remember these many formula. इतने formula आप याद कर लो, इतनी चीजें आप ध्यान में रखो. There is nothing else you need to keep in mind. ठीक है, बाकी सारी चीजें आपको अपने आप बन जाएंगी. आपको बस इतनी चीजें ध्यान में रखनी है. Okay. Now let's solve some most expected questions from torsion. Okay. So the first question that I have brought is based on the calculation of angle of twist. So angle of twist की calculation पे you will get a lot of PYQs. Okay, PYQs बहुत सारे मिलेंगे angle of twist के calculation में, especially in case of stepped shaft. So this is a question of calculation of angle of twist in a stepped shaft. Understand? A stepped shaft is subjected to twisting moment at B. Assume shear modulus G equals to 77 gigapascal. Angle of twist at C is. You need to find the angle of twist at C. Now, in order to calculate angle of twist at any point, what did I tell you? You need to find theta from that point to fixed point. तो अगर मेरे को theta at C चाहिए, तो मेरे को theta CA निकालना पड़ेगा. Okay. Why? Because A is fixed. Okay. So I can't calculate theta CB because theta CB में C will also be twisting, B will also be twisting. So I will calculate theta CA. Now can I write theta CA equal to theta CB plus theta BA? Up theta CB will be equal to what beta? Torque in CB into length divided by G into J. Okay. And theta BA will be torque in BA into length divided by G into J. Okay. तो मेरे भाई अब यहां पे हमको पहले तो टॉर्क निकाल लेना है. फर्स्ट वी नीड टू फाइंड द इंटरनल टॉर्क. So let's consider a plane between BC. So what will be the internal torque in BC? Can you tell me internal torque in BC? If I consider a plane here on the right side, what is the torque? Right side is plane के torque कितना है? 0 है. तो TCB will be 0 because there is no torque on the right side. अब left side अगर आप बोलोगे एक torque लग रहा है तो उसको resist करने के लिए यहाँ एक opposite reaction भी तो आएगा. तो 10 minus 10 0 ही हो जाना है. Now if I consider a plane between AB, then on the right side the torque will be 10 Newton meter. So TBA will be 10 Newton meter. So beta, this is the internal torque in BC and AB. Now put the values here. Length is given, G is given, J के लिए diameter is given. So beta just calculate it. So theta C will be equal to, अब ये तो हो गया 0, सॉरी TCB हो गया 0. This is gone to 0. I only need to put the value in this equation. So TBA is how much? 10 Newton meter. So I will convert it in mm. So 10 into 10 to the power 3 mm. Length is 500 mm. Divided by G is 77 gigapascal. So 77 into 10 to the power 3. And J will be pi by 32 diameter to the power 4. And diameter is 20. So this will become pi by 32, 20 to the power 4. So beta, how much theta you will get? How much theta you will get? I don't have the calculator. Let me bring my calculator. So this will become 4.13 into 10 to the power minus 3 radians. Okay. Now you can convert it into degrees. How? By multiplying 180 by pi. It will be converted into degrees. So can you tell me what will be the value of theta in degrees? 0.23. 0.2368 degrees. 0.2368 degrees. Yes, 0.2368 degrees. This is the angle of twist at C. Very good Gopalakrishna, Ayush, very good Ankita, very good Stavan, very good Kalpesh, very good Palak, very good Ayush, very good, very good, very good Raghul, very good. 0.2368, very good Akhil. Very good, 0.2368 degrees. Okay, so this is the angle of twist at C. Okay, so beta, angle of twist calculations are very important. Okay, next question that I have brought is based on the calculation of torsional reaction, statically indeterminate shaft. Okay, so you will see a lot of questions based on statically indeterminate shaft also. Okay, so let's see how to solve these problems. So let's say we have a shaft which is fixed at both the ends. Torque T naught is applied at some point. We need to find maximum shear stress in the shaft. Okay. Let me call this point A, this point B, this point C. So beta, let's understand first. The diameter is constant, but the torque in AB and BC will be different. What is tau maximum? Tau max की equation क्या होती है? Tau maximum is 16T by pi dq. So beta, in order to calculate tau max, you need diameter and you need torque. Diameter is same, but torque in AB and BC will be different. So beta, maximum shear stress can be in AB or BC. It will depend upon how much torque is in AB and how much torque is in BC. So in order to calculate that, I need to find the reactions. So let's say that the reaction here is like this, and the reaction here is like this. Okay, this is my assumption only. This is just my assumption. Okay, so I need to find TA and TC. So beta, in order to find TA and TC, we need two equation. तो एक equation तो क्या हो जाएगी? TA will be equal to T plus TC. TA will be equal to T plus TC. Okay, this is one equation. Now another equation will be theta between AC will be 0. This will be the compatibility equation, and theta AB plus BC will be 0. Now what will be theta in AB? T of AB will be what? A से B के बीच में if I take a plane, then torque will be TA. Length of AB will be what? L by 4 divided by G into J. Okay. Then theta BC, between B and C if I take a plane, from right side torque is TC, from left side torque is Ta minus T naught. I will write it Ta minus T naught so that I will get the entire equation in terms of Ta. If I write it Tc, ultimately I will have to put Tc equal to Ta minus T naught. ठीक है, तो बेटा Ta minus T naught यहीं पे कर लिया into 3L/4 divided by G into J equal to 0. तो यहां से I will get this Ta plus 3Ta minus 3T naught equal to 0. 4Ta equals to 3T naught, तो Ta will be equals to कितना आ जाएगा बेटा 3T naught by 4, and if Ta is 3T naught by 4, then Tc will be equal to how much? Tc will be equal to what? Ta minus T naught. तो Tc will be equals to minus T naught by 4. अब negative sign क्या दिखा रहा है? What is negative sign showing? Negative sign means my assumption of direction is wrong. Tc direction is wrong, but that doesn't matter because we don't want direction, we want the magnitude. तो मेरे भाई अब we need to find tau max. So which one is maximum? Ta or Tc? Ta is maximum, so I will calculate tau maximum using Ta. तो बेटा tau maximum will be equal to 16 into 3T naught by 4 divided by pi d cube. So tau maximum will be equal to how much? This will become 12T naught by pi d cube, right? 12T naught by pi d cube means this will be the answer. B will be the answer. Yes, Sunil. Yes, Ayush. Yes, Kalpesh. Yes, Ankita. Yes, yes. Very good. Very good. Please hit the like button. Those of you who are watching me live. Yes, Palak. Yes. Very good. Very good. Very good, Sveksha. Very good. Very good, Shivam. Very good, Prem. Very good. Very good. So, beta, tau maximum will be 12T naught by pi d cube. Okay. So, this is another very important type of question. Statically indeterminate shaft. Statically indeterminate shaft के ऊपर काफी questions आते हैं. Very good, Zubair. Very good, Akhil. Very good, Nitish. Very good, Vikas. Very good, beta. Very good. So, let's move on to the next important question. Expected question. So, the next expected question is based on calculation of strain energy. So let's say we have a stepped shaft subjected to torque and we need to find strain energy. Now in order to calculate strain energy, let's say this is A, let's say this is B, let's say this is C. So in order to calculate strain energy, I will have to consider AB and BC separately. Okay, let me just turn on the battery. Okay, so my laptop was not turned on, the charger was not turned on, so the battery was about to die. That's why I had to turn on the battery. Sorry for that. अरे हाँ मेरे भाई अंकित ले लिया यार तुम्हारा नाम. Okay, so beta we need to calculate the strain energy in this shaft. Okay, so in order to calculate the strain energy in the shaft, I need to consider AB and BC separately. I will calculate strain energy in AB and BC separately and I will add them, है ना? तो मेरे भाई U will be equal to U of AB plus U of BC. अब U कैलकुलेट कैसे करते हैं? कैन आई राइट इट T square L by 2GJ of AB plus T square L by 2GJ of BC. Yes, I can write that. Put the values in the formula. That's all you need to do. Put the values in the formula. ठीक है? Put the values in the formula. तो मेरे भाई torque in AB कितना होगा? What will be the torque in AB? From left if you see, torque will be 20 न्यूटन मीटर. तो ये हो जाएगा 20 into 10 to the power 3 का स्क्वायर. Length of AB will be 100 divided by G is 80 gigapascal and J will be pi by 32 into 25 to the power 4. This is T square L by 2 Gj of AB plus T square L by 2 Gj of BC. So what is the torque in BC? If I consider a plane in BC, on left side total torque will be 20 minus 50, matlab 30. So that will become 30 into 10 to the power 3 ka square. Length of BC is 150 divided by 2 into G into J. Diameter of BC is how much? 50. So just put the values in the formula and you will get the answer. Okay. क्या आ रहा है? Can you tell me? .894 Newton mm. Vikas and Kalpesh are getting the answer in mm. I don't know why. Beta, it will be Newton mm, okay, not mm. So I am getting 7.894 Newton mm. Am I wrong? How am I wrong? .894 Newton mm. 7.894 Newton mm. Are you getting this? 7.894 Newton mm. अरे भाई कोई तो सही आंसर निकाल लो. यस गोपाला कृष्णा, यस यस ब्रदर, यू आर राइट. U will be equal to 7.894 न्यूटन mm. बाकी लोगों का कैलकुलेशन पता नहीं कहाँ जा रहा है. एक तो लोगों के mm में आंसर आ रहे हैं. यस 7.894 न्यूटन mm. यस गोपाला कृष्णा 7.894 न्यूटन mm. Other people are getting 20.66. गोपाला कृष्णा is getting 7.894. Why? एक बार चेक कर लेते हैं. Let me check. 20,000 square into 100 into 80 into 3 into pi into 25 to the power 4. Okay. Then 30,000 square into length 150 divided by 2 into 80 into 10 to the power 3 into pi into 50 to the power 4. 7.894 I am getting. Why other people are getting? Zubair is also getting 7.894. Shivansh is getting something around 7.894. Ankita is also getting 7.894. Okay. Utkarsh is also getting 7.894. So I will assume that this is the right answer. 7.894 Newton mm. 7.894. Yes, 7.894 Newton mm. So this is the strain energy stored in this shaft. So do you understand what type of questions you can expect in exam from torsion? ठीक है, मेरा अंदाजा है, my prediction is that you will get question on calculation of angle of twist, or you can get a question on statically indeterminate shaft, or you can get a question on calculation of strain energy. Yes Palak, yes Shivam, yes Zubair, yes Prem. 7.894. Okay. Thank you so much. बेटा इसी बात पे everyone who is live, please hit the like button, please share, and please write in comments what do you like about this lecture. Okay. Now beta, this was all for today's lecture. Tomorrow's lecture at 7:30 p.m. will be based on shear force and bending moment diagram. Yes, our favorite topic, shear force and bending moment diagram. So tomorrow we are going to completely revise the chapter of shear force and bending moment diagram. Every day we will cover one particular chapter, okay, and within 1 hour I will complete the lecture. 1.5 hour maximum. 1.5 hour. Otherwise, in 1 hour only, I can complete the entire chapter, all the important concept, all the important formula, all the important questions. Okay, so this is about the revision of strength of material through questions and concepts. Okay, now beta, don't forget to join this Telegram channel, follow this Telegram channel, because all the notifications and links of my classes I will put in this Telegram channel. This is my personal Telegram channel. Only I operate this Telegram channel. Only I post in this Telegram channel. So everything related to my classes you will find here in this Telegram channel. Okay. And if you want to download all my lectures and PDFs, then you can go to this link tinyurl.com/approved10. The PDF of this lecture will also be uploaded either here, या तो आपको PDF यहाँ मिलेगी या तो आपको PDF यहाँ मिलेगी. Okay, I will make an Excel. I have made Excel sheets of all these lecture series. हर lecture series की एक Excel sheet है. For example, this is the lecture series SOM revision. तो बेटा SOM revision के नाम पे you will find an Excel sheet. Open that Excel sheet and you will find the PDF, or you just go to this Telegram channel, follow this Telegram channel, and you will find the lecture series, like you will find the PDF. Okay, now if you want to study with the legendary educators in the new batches for GATE 22, new batches have just started. Okay, new batches have just started for GATE 2022, for GATE 2023, and for ESE 2021. Okay, recently these 3 new batches have been launched by the top educators of Unacademy. Unacademy मैकेनिकल इंजीनियरिंग के जो टॉप एजुकेटर्स हैं उन्होंने मिलके, हम सब ने मिलके नए बैचेस लॉन्च किए हैं 22, 23 और 21 के लिए. ESE 21, GATE 22, GATE 23. So if you want to study in these batches, if you want to join these legendary batches, then you take Unacademy Plus subscription or Unacademy Iconic subscription. What do you get in Unacademy Plus? You get live classes, batches in English as well as in Hindi. You will get doubt solving, which is the most important thing. Just by watching the lecture, you are not going to get good marks. You need to clear all your doubts regarding that topic, regarding that chapter. Okay, you will get weekly test. Every week there will be a test based on the syllabus of that week. Okay, you will get crash courses, multiple crash courses. You will get rank improvement batches. Okay, this is in Unacademy Plus. Additional to this, in Iconic subscription, you are going to get a personal coach. Iconic subscription में आपको एक personal coach मिलेगा who will personally look after you. आपको वो पर्सनल अटेंशन देगा, आपको वो पर्सनल गाइडेंस देगा. पर्सनल गाइडेंस, पर्सनल अटेंशन का मतलब क्या है? ही विल मेक द एंटायर शेड्यूल फॉर यू एंड ही विल मेक श्योर दैट यू आर फॉलोइंग दैट शेड्यूल. ओके, देन बेटा he will prepare all the study material for you. He will take one-on-one sessions with you in order to understand what are your strengths, what are your weakness. Okay, so this is what you are going to get in Iconic subscription. Now what will be the advantage of Unacademy platform? So Unacademy platform is India's #1 learning platform. There are so many tools which will be really helpful in online learning. For example, live polling and leaderboard. Whenever you have objective questions like this, अगर आपके पास objective question है, then the teacher will create polling which will be like quizzes. Within 2 minutes, answer this. So you will answer A or B or C or D. Now after 2 minutes, there will be a scoreboard who will tell you what is your rank, what is your timing. So beta, this will have many advantages. It will create a competitive environment in the class. So you will try to do better and better. And it will also improve your time management, because in a particular period of time you have to answer. So your time management skill will improve. Then live interaction. What do we mean by live interaction? Beta, if you are interacting with the teacher on Unacademy, you will feel like you are sitting in front of that teacher. It is that interactive. The comments that you put here will be live, 100% live. The teacher will look at your comments and answer you immediately. And if you have a big question to ask, you can just take the picture of that question and you can attach it in the class so that the teacher can watch that attachment and he can solve the problem. So the interaction is quite good in Unacademy. You will feel like you are sitting in a classroom with your teacher, okay? And if you are thinking that you are not going to get enough time for doubt solving, there are so many students, how I will get time to ask doubts? Though no problem beta, every fourth lecture here is a doubt solving lecture. Means in that lecture there will be only doubt solving. So you will get enough time, ample amount of time to ask all your doubts, to clear all your doubts. And the best thing is, there are multiple batches, so many batches for GATE 21, GATE 22, rank booster batches, ESE batches, so many batches, and you can be a part of every batch. With one subscription, single subscription, you can attend all these batches. And all these batches are taught by the best of the best educators of India, okay? And you can attend the batches of GATE, ESE, PSU, you can attend the batches of ME, XE, PI, whatever branch, whatever exam you want, okay? So this is the best advantage of Unacademy. One subscription, many branches, many exams, okay? And beta, if you want to take the subscription, then just go to your Unacademy learning app and choose any one of these plans, okay? You can choose 1 month to 2 year plan, but I will suggest you take 2 year, 1.5 year or 1 year plan, because the per month cost is very less. Compare the per month cost of 1 month plan and 2 year plan. There will be a huge difference, okay? And you can use this code. आप ये code use कर सकते हैं, approve 10, in order to get maximum 10% off. So beta, you will get instant 10% off, and the best advantage of using this code is, if you are using a code, if you are using my code, means you are coming to Unacademy believing in me. अगर आप मेरा कोड यूज करके आ रहे हैं, मतलब आप मुझ पे भरोसा करके आ रहे हैं, एंड अगर आप मुझ पे भरोसा करके आते हैं तो मैं आपका भरोसा छोड़ूंगा नहीं, आपका साथ छोड़ूंगा नहीं. आपका जितने का भी सब्सक्रिप्शन हो, 1 ईयर का, 1.5 ईयर का, 2 ईयर का, आई विल बी देयर विथ यू, गाइडिंग यू, मेंटरिंग यू, पर्सनली हेल्पिंग यू as much as possible, okay? And you can pay this fee in EMI without any additional cost. बिना किसी additional cost के आप EMI पे pay कर सकते हैं. You can see that per month cost is 1650 and per day cost is only 54 rupees. तो बेटा इतना affordable बना दिया है Unacademy ने education को, okay? Best of the best teachers, best of the best batches at this cost, 50 rupees per day, almost 50 rupees per day. This is the magic of Unacademy, okay? So believe in Unacademy, believing in us, and take Unacademy Plus subscription. You can also take Unacademy Iconic subscription for 1 year or 2 year in order to get a personal coach, personal attention, okay? Now beta, before leaving this class, don't forget to hit the like button, share the link and subscribe to this channel. Thank you so much for joining. I will see you in the next class tomorrow. Till then, bye bye, take care, good night.